We're given a trig integral evaluated from 0 up to pi of sine 3x times sine 5x. And this doesn't appear to be an integral that can be easily evaluated via u sub, and so we'll have to turn to some trig identities. Immediately, the one that I think jumps out at me is a product to sum identity, where sine a times sine b equals 1/2 times cosine a minus b minus cosine times a plus b. And so looking at our original integrand and fulfilling this formula, we have sine 3x sine 5x equals 1/2 times cosine, and in this case our a value was 3, times 3 minus, and of course b here is 5, minus cosine, a again is 3, plus 5 for b, and what we result with here when we simplify is equals 1/2 times cosine 2x, because these also have x's, I forgot to include those, x's after all those, minus cosine 8x. And you might be wondering why this is a positive 2 when this clearly evaluates to negative 2x. And that's because cosine is an even function, and so when cosine of negative theta exists, it equals cosine of theta. And so now we can go ahead and plug our result here back in. And so what we've got is the integral evaluated from 0 up to pi of 1/2, and we'll put the 1/2 out front of the integral, times cosine 2x minus cosine 8x dx. And these are values that can be fairly easily evaluated. So what we've got is 1/2 times, of course, the integral of 2x with respect to x is sine 2x over 2, minus, of course, the integral of cosine 8x is simply sine 8x over 8, and we're going to evaluate this from 0 up to pi. And there's already a pattern that has jumped out to me, but we'll go ahead and work through this one. What we've got is 1/2 times sine 2x, and x here replaced with pi, so that's sine of 2 pi over 2, minus sine, and again we'll plug in pi here, of 8 pi over 8, and then we'll subtract in parentheses sine of 0, because we're plugging in the 0 here, over 2, minus sine once again of 0, this time over 8. And so the pattern that jumped out to me immediately was, if you recognize on the unit circle where each of these will go, intervals of 2 pi for sine wrap around the whole way to here, where of course the y value with respect to the origin is 0. So sine of 2 pi is 0. Similarly, 2 pi shares the same landing spot as 0 does. And so sine of 0 is also 0, and we have that twice here. And yet again, sine of 8 pi is simply 2 pi, but going around it with 4 more revolutions, and so that lands in the exact same spot. So this is also 0. And so what we've really got is 1/2 times 0, which is just 0. And this is the result of our integral. If you have any questions, leave them in the comments below. Otherwise, I hope that you found this helpful.